Midterm, one final.
Huh? No, there is no midterm. I mean, there's no two midterm. You can't have two midterm.
What is a midterm?
Oh, no, maybe
One
that's
is in
two.
the middle of a term, so that's test two probably.
That's two.
it?
All right,
Midterm
that
account
was
is test
all
two.
little review.
There's a-
Let's start on the next section. Okay. 2.1, we're going back to 2.1.
Oh, my.
You reviewing?
Yes, we haven't covered it. The reason why we wait so late is because this is actually like one of the hardest sections. So it just doesn't make sense to start with it because it's just one of the most hardest sections we have. Okay, so that's why we kind of waited on it. Okay, so the slope of a, well, we know a slope of a line, the slope of a curve. Slope of a curve. Just get a slope of a curve.
What?
See what this is, tangent lines. Okay. Okay. Okay, yeah, so I won't say it often in terms of the sections that we cover, but like there are some sections that are more important than the others for this class. So it turns out that this section, 2.1, 2.7, 2.8, they're all one idea, just one concept. It just takes 3 sections to practice it, right? But these this is basically the most important section of the course. Okay, so here's where you really want to put an effort. In fact, everything that we do in chapter 2 is all geared so that we're able to do this section. Right? The whole point is to get the tools to be able to do this kind of a section. Most important section of the course. Okay, so it'll be a while before I say it again, but it really is the most important couple sections. So, you know, it just takes 3. You can combine them all in one basically, but it takes a while to get across this idea. Okay, so suppose we have a function that's, let's say, f of x is, let's say, a portfolio value, like a stock portfolio value. X is time, could be like the number of years. Okay, so we're used to, you know, having a good idea of, you know, whether our portfolio is doing well or it's doing poorly. So like my portfolio is going like this. Is that good or bad?
Good.
Yes, good, right? Rising, right?
Oh, wait. For me, that looks negative.
Yeah, maybe I'll go like this. Portfolio going like this, good or bad? Good, right? How do we measure that? Well, I guess it's like if it's a line, the slope is big, you know? Slope is big slope. That means it's increasing, you know, the stock portfolio. What if it's going like this? Going down. There's Bitcoin. When was that? Right, not going so well. What if it's like more flat?
It's not good actually.
Right, it's kind of not doing much. So in terms of lines, we kind of understand that a bigger slope means things are increasing fast. You know, if a big negative slope like -100, things are decreasing really fast. Okay, so in terms of lines, how would this look like? If it was a line, f of x. Okay. Okay. So how do we measure that? So here, let's say we got a pretty good stock portfolio. Things are increasing, things are good. How do we measure? How do we quantify how good it is? Well, the slope, how fast it's growing will tell us how good you know, our portfolio is. So you can just take 2 points, x1, x2, and 2 points on the graph to get the slope. So this is f of x1, and this is f of x2. So we have an x value and a y value, and we can get the slope of these 2 points, between these 2 points. So slope m, as you guys know, it's rise over run, right? Rise over run. So the rise, the 2 y values, f of x2 minus f of x1 divided by x2 minus x1. Okay. So we get a big value, portfolio is doing well. Negative value, portfolio is doing bad. 0, it's not changing. Right. So you guys see how this is the slope? The slope between these 2 points. Okay, now here's the problem. This is for a line. You can get the slope of a line. You could see how a function's increasing. Right? What if it's not a line? Right? But what if f of x is a curve? Well, how do you know how well you're doing? Here's x, here's y. You know, so let's say it looks something like, I don't know, like this. Here's f of x. Okay. Well, now how are we going to figure out if the portfolio is doing well? Right. Well, it depends on which point you're at, right? We're at negative time, you know, below a certain date. Notice how the function is decreasing at that point, right? Your portfolio value is going down, right? And what about over here around this area? What's happening to the value? Yeah, Matt.
It's going back up.
It's going back up, but it's kind of slowly. You know, let's say I flatten it out a little bit. A little bit neutral, right? And then what happens to it?
Increases.
Right. Then it starts going back up. And then over here, it kind of a transition zone, you know, stays a little bit neutral and then goes back down. Okay. So we want to quantify that, you know, just like we see here, the portfolio is rising. We want to be able to get what's called the slope of a curve. The slope of a curve to tell us at a specific moment in time, are things rising, are things falling, or are things staying steady? Okay. So let me do color coded. Color coded. Okay. So let's say we have a specific point. Let's call it P. Let's call it point P. Okay. And it's located at x1 and f of x1. Okay. So in order to capture that things are rising at P, like the portfolio value is rising, what we want is the slope of the tangent line. It's called a tangent line. We want a slope of what's called the tangent line at P. Line at P to capture how fast portfolio rising, I guess portfolio value rising at P. See, notice how the tangent line has this positive slope. Right, so that's what we mean by the slope of a curve. So the slope of a curve means at each point, we could make like this tangent line that captures how fast the function is increasing or decreasing. But we don't have 2 points, right? We don't have 2 points. So since we don't have 2 points, we can't just use the slope of a line using 2 points. We only have 1 point. Okay. So instead, what we're going to do, we're going to estimate it. Right. We're instead going to pick a different point on the graph. Let's call it point Q. Okay. And we'll see how the function changed from P to Q. Right? P is at a certain moment in time x1. Q is at a certain moment in time x2. Right? And we can capture how fast the portfolio value rose from x1 to x2 by instead making what's called a secant line. And a secant line, it's called a secant line. And secant comes from the word two. We have 2 points. So we have 2 points on the graph. We can make a secant line. And we want the slope. We want slope of secant line denoted. So the book uses MPQ, the secant line between points P and Q. I think what I'll sometimes write is MPQ sec, so that you understand it's a secant line between 2 points. Okay. So this is x2 and Q is located at f of x2. Right, so now I have 2 points on my graph. Right, I have 2 points on my graph, I can get a slope. I can get a slope between these 2 points. So M PQ secant line is going to be change in y, which is f of x2 minus f of x1 divided by change in x, x2 minus x1. Okay, so rise over run. So I don't have a tangent line because that requires 1 point, but I can still get a secant line. So it at least tells me sort of an average. It tells me an average of how much the function rose from P to Q. Okay, it's an average. What we'll do later is we'll bring Q closer and closer to P. That'll help us get a tangent line. But at least from P to Q, we can get an average. Okay, so let me show you guys an example. Any questions on this so far? Do you guys understand what I mean by the secant line? So it's 2 points on the graph, just the line between them and the slope of that line. Layla?
Yeah, is the average of the values from point x1 to x2.
Exactly, yeah. So it's not going to give us, like right here, let's say the slope was m equals 3. So that means like every year the portfolio rises up by 3. So if here, let's say the slope was, let's say 2, so that means on average, it rose by 2 units for every year. Okay, so it's how fast it's rising on average. Yeah.
So we find the average from the secant line.
That's right. The slope of the secant line. Yeah, the slope of the secant line, I could even write it This is the average. So secant lines give you average rate of change of f from time x1 to x2. So just on average, how fast the portfolio is rising. So, it's doing a lot of things in between. It like rises up and it comes back down. But if you get a slope of a secant line of 2, that means on average, it's rising $2 per year. Pretty bad. Let's do it in millions, $2 million per year. That's good. We make it in millions. Okay. But just an average, right? Just on average, how fast it's rising. Okay. So that's what a secant line is giving you. It's giving the slope of a secant line is giving you on average how much it's changing to go from P to Q. Good. Well, the best thing that we can get is the tangent line. We don't have access to it yet. So we'll need to use a couple tricks to get it. So a tangent line will tell us exactly at P how your portfolio is doing. And then a tangent line would tell you at every point how your portfolio is doing at every point. So we don't have access to it yet. So we'll just settle for an average. Right? We're just kind of settling for second best right now. Yeah, good question. Good, other questions? Yeah, so slope of a secant, average. Any physics majors? Or anyone that likes physics? Physics, yeah. So this formula is actually familiar from physics because if F was not a stock portfolio, it just measures the position. Let's just say it measures the position of an object, like your car is traveling. So it's telling you the position of your car. Well, then what is the secant slope telling you? Well, it's change in position divided by the change in time. Right. So what change in position divided by the change in time? Right, which is its velocity. Velocity. But more particular, so the numerator is displacement, that's right. And the denominator is time. So more particular, it's called average velocity. So when you guys learn physics, this was your formula for average velocity. And here, we're just calling it the slope of a secant. Yeah. Okay, so let's actually do an example computing it. So MPQ. So just be careful, guys. In the book on your website, they don't write out the word seek. They don't write out the word seek. But if they say PQ, they're asking for the secant line. Okay. Example. Let's see. So let's say f of x is equal to x squared. So let P be the point 1, 1. First of all, does the point 1, 1 make sense? Is 1, 1 on the graph? Like the problem will start out this way, but you could check, does it even make sense? Yeah, because if I plug in 1 for x, the output is 1. Like they can't tell you the point P is 1, 2, because 1, 2 is not on the graph. Okay, so they're giving you a point that's on the graph, and they'll say, find MPQ secant, i.e. slope of secant line from P to Q, where Q has X values, X equals 0, 0.5, 0.9, 0.99, 0.999. Okay. Now Q lies on the graph of F. So remember the point Q, it's on the graph. So whatever X is, the Y coordinate is F of X. Okay. So we just need the slope of a line between 2 points. Okay, so I guess, what should I call this? Step 1, maybe? Okay, they want you to get the slope of a secant line, which is basically the average rate of change for all these X values. So X equals 0. So what's Q? What's point Q? If X is 0, what's point Q on the graph? Right, 0, comma,
0.
0. How do I get the Y value? What do I do? Right, I plug 0 into the function, right, into X squared. So 0 squared, which is 0, comma 0. Okay, so then MPQ. Okay. Is just the slope between P and Q. Y2 minus Y1 and X2 minus X1. So it's just 0 minus 1 divided by
0 minus 1.
0 minus 1. Right. So what slope is that? 1. Okay, just slope 1. Okay, so let's try another one. Let's do X equals 0.5. Okay. So X equals 0.5, you have to figure out first, what is Q? Right, the X value for Q is 0.5. What's the first coordinate of Q?
5.
0.5. And how do I get the second coordinate?
Plug it in the function.
Plug it in the function.
0.25.
Right, so 0.5 squared, right? So 0.5 squared, 0.5, comma, 0.25. So MPQ is going to be equal to, so just use the slope of a line. Now this is your Q. So Y2 minus Y1, so 0.25 minus 1. And let's say 0.5 minus 1. Matthew?
So 75.
Let's see, so negative 0.75 in the numerator and the denominator,
0.5.
negative 0.5. Okay. Okay, and that'll be, we could simplify it as 1.5. So I'll give you guys a chance. Why don't you guys do? You'll have a very similar problem on the WebAssign, so you might as well try this here. Do X equals 0.9, 0.99, and X equals 0.999. Okay, so we're picking all these points where X is getting closer to 1. Okay, so try that, and I'll do this at 3:47. If you need a break, take a break, but otherwise see if you can get the slope of these secant lines, and then see if you can get a pattern out of it.
Finally, but I wonder. Idiot.
Huh?
It's true. You should eat. It's a meat today. I can get to like have a tension. Really the series, but not doing it. We should be doing. Oh yeah. It's only like a week. It's not happening. I would just like wait until. The days getting shorter. They're still getting shorter. I gave up. I gave it a 0.5. Actually, no, a 0.9. I'm not he's gonna check. It's for yourself. Give it. Just read the simplified. You're all right. You know, and you give me because you know when it comes to touch. I mean, like, I'm not completely wrong though. Like, I got the hard one right. Same thing for mine. No, it's the fact that, like, I was late, so I didn't know y'all were doing it too. And I was right. I was like, guys, this doesn't look right. The question was like, like, no, I'm not the vibe. I did not know that. Google. You know what? I didn't do. I know. Prayer. They're not your homework. Wow. Why don't you do it? What's up? It's like the best way to review this too. Hey, wait, wait. 1.9 to 0.5. That doesn't make sense. I'm expecting to like get closer to 2. Did I do this wrong? Did I do it wrong?
The first one. This one? Yeah, the lamp.
Okay. What is going on?
Let's go with this. Just change this.
I would never admit that. Would you? Would you ever admit that you know that I kept them? I think you'll know. Yeah, but like in my heart, I was like I might say it out loud. Yeah, I'll never actually believe it. I wait for It's weird. On the one hand, like I have a lot of pride, but on the other hand, I have like no confidence. I got 1.9. Step 4. For 0.98, that makes sense, like logically, but I didn't get that. I don't know why. Did I like? I'm so glad. I did not. Oh. It's literally just you square the stupid piece of shit, and that's that. The division. Where did I go wrong?
What caused that?
See, things like this makes me feel unimpressed. Like the message. Thank you though. I got here, 'cause I Yeah. I knew it was wrong, but like I could feel it. I just, you know, because there's supposed to be a pattern. So it's not like, yeah.
Okay, guys, for x equals 0.9, so let's do this. So what's point Q that you're gonna use? What are you gonna use for the Weber sign? What's Q? Okay, the first coordinate is always what they tell you, it's 0.9. But how do we get the second coordinate? Yeah, Rachel? Plug it in and what do we get? 0.9 squared, right? Which is what? 0.81. Okay, once you guys get your 2 points, you can get the slope of a secant line. So your MPQ, y2 minus y1, so 0.81 minus 1 divided by 0.9 minus 1. Negative 0.19 negative 0.1 is equal to 1.9. You guys see how we get that? 0.99, Q is gonna be, well, 0.99 and then 0.99 squared. Okay, just make sure you guys, when you're doing the homework, you're not putting 0.99 squared, you're putting it into the function. Right, P and Q are 2 points on the graph, so you have to put into the function to get the y value. Okay. So I'm only squaring it because my function is x squared. If it was x cubed, I'd cube it. If it was x cubed plus 1, I'd do x 0.99 cubed plus 1. Okay. Keep in mind you're using the function. So then MPQ is going to be 0.99 squared minus 1 divided by 0.99 minus 1. And then when it simplifies, it should be 1.99. That'll be the slope, 1.99. Let's get even closer to 1. See what I'm doing is I have point P, and what I'm doing is I'm taking a point Q that's getting closer and closer to P. And that sort of lets me estimate the slope at P. It's giving you, technically it's an average slope from P to Q, but when P is so close to Q, it's essentially giving you the slope at P. How fast the function is changing at P. So let's do this. So Q is equal to 0.999. 0.999 squared. Okay. So MPQ is 0.99 squared minus 1 divided by 0.999 minus 1. And that'll end up being 1.999. Okay. Does anyone see a pattern? What's happening to the secant slope as Q keeps getting closer to P? Yeah, Agate?
Once it gets to 1, limits goes towards 2.
Right. See how the slope, it keeps getting closer and closer to a number? It's getting closer and closer to 2. Yeah, so we could even draw that, right? What it's doing is it's helping us get what the tangent slope is. Okay, so let's actually draw what this looks like. F of x equals x squared. Okay, so here, maybe this is 1. Okay, so here's point P on the graph. Right, here's point P, and then the first Q that I had was 0, 0, right? So I had Q being 0, 0, and I got this slope right here, right? The slope, the secant slope for this one, what do we get for 0, 0? We got 1. Right, so how fast is the function increasing from point Q to point P? About 1 unit. Okay. Yeah, for every when you go to the right by 1, it's increasing by 1. Then what do we get? X equals 0.5. Let's use a different color. So X equals 0.5, we use this Q. This was our Q at 0.5. And what we did is we got the secant slope from Q to P with this slope. Okay. And this one was M secant. What slope did we write? We wrote 1.5. Right, so on average from Q to P, it's rising 1.5 units for every 1 unit. That's the slope.
How many secant slope can you have from point Q to point P?
Once you fix the Q, or like you change Q?
You change.
Oh,
Q.
infinitely many, yeah. We could keep, we can make Q anything. For any X value, we get a Q, and then we can get a secant slope. So infinitely many. So that's why we want to kind of pick the ones we like. What we want is to get a tangent line at P. So that's why we're picking Qs that are getting closer and closer to P. Yeah, Matthew.
How does WebAssign ask questions like this?
So I think a couple of questions I think are just like this. They have a Q, different X values for Q, and they just want you to get slopes,
Okay.
a bunch of slopes. So you can take a look. You'll have a question that'll be just like this. Yeah. Let's see, can I use one more color? I have one more color left on my pen. So here, let's say it's 0.9 in green. So that's the Q. So then I could make a secant slope here, which was M equals 1.9. So it's getting closer to 2. And can you guys picture like what happens if I take point Q and I bring it closer and closer to P? Right, I just bring it really, really close so that the point Q is so close to P. What it's giving us is pretty much the slope of a line that's just going through P. It's almost as if there is no Q anymore. So we could illustrate it here. There are all these applets here online so that you could see what this looks like. So here is 1. So I put in f of x equals x squared. And see this blue point is 1, 1. Do you guys see 1, 1?
Yes, sir.
And this point right here is Q. Right, this point right here is Q. And it's drawing a green line, which is the secant line going through them. And what happens is I can vary, see H is the distance between P and Q, the horizontal distance. So I can vary this horizontal distance and bring Q closer. You see how I'm bringing Q closer and the secant line, it starts approaching a certain slope. I could keep going closer and closer, and I could take like a limit. And eventually in the limit, Q will line up to P. Not like that. What? And you'll get a line. And here's the tangent line is in purple. So what happens, the secant line is in green. I don't have access to the purple line, but I'll bring Q closer and closer. And the slope will approach the tangent line. That's the slope of a curve at P, right? So that's why we need limits. That's why we spent how many hours now?
A lot.
Doing limits,
Way too many.
at least 10 hours. How many days? Section 2.2, 2.3, even 2, yeah.
Secant and tangent.
Yeah, so see, it's a good point. Why we call it secant? So secant comes from two, so 2 points. That one's a little bit easier for to define. You know, it's not. It's a maybe a Latin word, right? So it's not an English word. It's coming from a certain root, coming for two. Tangent line is a little bit harder to define, and I can't really give a definition that works for all cases. But if the curve is curvy, a tangent line will go through just 1 point on the function on the graph near that point. Okay, so I can't give a definition that works for all cases except for giving you an intuitive definition, where secant, the root is coming for 2, and then tangent is we're practically trying to get a line intersecting the curve at 1 point nearby. Yeah, it might intersect another point later on, but at least in the vicinity of P, we're calling it tangent. Okay. I think slowly we'll work up to a better definition so that we'll have a better definition of what it is. Okay, that's a good question. Okay, so that's going to be the idea. So the secant line slope will give us an average. And then in the limit, we're actually going to get the exact slope at P. So that's what the slope of a curve refers to, right? We know the slope of a line, but if we have a curve, the best we could do is at every point in the curve, what's the slope? So how fast the function is increasing at a point P is the slope of that tangent line. So let me show you guys how that looks. Okay. Okay, so I'll show you how we formally bring Q very close to P. Okay, so we have a function. And let's make P right here. At a point A, the X value will be A. And in terms of being close, we're just going to call the X value of Q A plus H. Right, instead of calling it X1 and X2, we're just going to call P wherever P is located A, and wherever Q located as A plus H, just because we're thinking of H being small. So the distance here is H. This is the function f of X. Okay. So this Y value is f of A for P. And what's the Y value for Q? It's f of what? What should I write? So the Y value for P is A f of A. So Q will be A plus H. Well, the Y value is f of what? A plus H. Okay. Okay, so if I did a secant line, so MPQ, the secant line Y2 minus Y1, so it's just a change of notation. Just change of notation where we use H. So it doesn't really matter, but we could change notation. So y2 minus y1 is f of a plus h minus f of a. Subtract the two y values and subtract the two x values, a plus h minus a. So it's f of a plus h minus f of a
H.
divided by, yeah, let's keep it as h. Divided by h. Okay, so using this notation, so similar thing. The only thing that changed is now x2 minus x1. We're just calling x2 minus x1 as h. Okay, so just a change in notation. Okay. So here's a definition. The slope of a tangent line at a comma f of a is, so the notation we're going to use is m, and I'll write a, and I'll write tan for tangent line. Okay, and what we're going to do is what we did, we're going to take the slope of a secant line. So this is f of a plus h minus f of a. So we'll take the slope of a secant line divided by h, right? So rise over run, the slope of a secant line. Now a tangent line is we bring q close to p. So how do we bring q close to p? We take h going to 0. We're going to take the limit as h goes to 0. And that'll give us the slope of a tangent line. Okay. In terms of this picture, here is the tangent line at P, right, which we don't have access to. All we could do is take the slope from P to Q. That's what this a plus h thingy is. That's the slope of a secant line. But we could take limits afterwards. So this red line, the slope is MA tangent. Okay, so that's what it's giving us. So this formula is telling us the slope of that tangent line. Right. And what is this slope? It's the slopes of a bunch of secant lines that we just did, we computed. But we're doing a limit, so we get the whole pattern. We get the whole pattern of slopes, and that gives us the full slope of a tangent line. Yeah. First of all, since it's a limit, what happens if we plug in h equals 0, right? Whenever we do limits, we like check where we're at, where it's h equals 0. What happens if we plug in h equals 0? What's the numerator?
F of A.
So
Wait, no, it's F of A minus F of A.
f of a minus f of a, right?
Yeah.
What's that?
0.
0, right, good. Right, so you guys see how the numerator is 0 and the denominator is 0. It's a 0 over 0 case, so it's always going to be 0 over 0, right? Which means we could always do algebra, right? So in order to compute it, we always get a 0 over 0 case. We could just do algebra like we did in the other homework problems and get an answer. So as an example, let's do an example, guys. So let's see, f of x is equal to x squared. Compute M1 tangent. Right, so it's the tangent line, i.e. the slope of tangent line at the x value is 1 comma 1 squared. Okay. Now, we already know what it is from the previous problem, right? We're just going to do it algebraically using the formula, but we know what it is because we got closer and closer to 1. What were the slopes of the secant lines? It was like 1.9, 1.99, 1.999, right? The slopes kept getting closer and closer to 2. Okay, so we know we need to get 2. Okay, just by doing it by hand from secant lines. Okay, but now we could actually do this with limits much faster. Okay. So how do you start this? So step 1. Right, so the slope of a tangent line, we're just going to use the formula. A is equal to 1. So it's the limit as h goes to 0. F of, okay, notice that the a value here is 1. Okay, they have to tell you which a value to use, right? So they're telling you to use 1. So this is f of 1 plus h minus f of 1 divided by h. Okay. Do you guys see that? How I took the formula, you have to fill in what the a value is. Okay. The problem is going to give it to you. I think maybe 1 or 2 problems just ask you for the slope at any a, but usually they just tell you what a is. So here they told me it was 1. That's why I plugged in a equals 1. Okay. Okay. So to use this formula, okay, maybe I'll do a different color. Right, the input here is 1 plus h. It's all one input. So that means this input gets substituted for x. So x is replaced by the input 1 plus h. Okay. So limit as h goes to 0. I'm going to plug in the input 1 plus h. So I get 1 plus h squared minus what? What's f of 1? 1. How do I get that? Yeah, what do I plug in? 1 into x squared. So 1 squared, which is 1. And you'll have the h. Okay. Now it's always a 0 over 0 limit. So that means algebra should save you guys here. So try it. Take a minute. Do the algebra. The only algebra you could do here is really just foiling it out. So see if you could foil it out and get the h's to cancel. Eventually the h will cancel. So try to foil it out and get the h to cancel.
Cool.
Okay, let's see. So let me call on somebody. Let's see, Mahadin. Mahadin's here. What happens when you FOIL this out? What did you get?
It turns into h squared plus 2h plus
Good, h squared plus 2h plus 1. And what did you do to simplify it?
I just subtracted the 1 and the 1.
Good, so the ones cancel. Were you able to simplify any further?
Yes.
So you got up to here, Okay, let's see how that looks. So limit h squared plus 2h divided by h. I could factor the numerator. How do I factor the numerator? Yeah, Sandra? Right, limit h times h plus 2 divided by h. Could factor an h. What do I do now?
Cancel
Ready?
the h.
Cancel the h. Okay, once I can cancel, I could usually just plug in. So what happens if I plug in? 2. So I cancel, I plug in 0 plus 2 is 2. That's the slope. That's the slope of the curve. So that means at 2, this is stock portfolio, your portfolio is increasing just at time 1, at time equal 1 year. So $2 per year. That's how fast it's increasing when you're at 1 year. If you do better at 2 years, we'll see. Maybe it'll be increasing faster. Okay, any questions on this, guys? Okay. So this formula, right? This is going to be the formula we're working with for a while. Okay. We're going to be trying to understand this slope. That's the slope. A part B usually to this question is right equation of tangent line. Of tangent line. Okay, to write the equation of a tangent line, there's not much work to do because they already gave you the point, right? The point was 1, 1. So you have a point, which is 1, 1, right? And then you have a slope, which we have, m equals 2. So a point and a slope, we could write down a tangent line. Remember, a tangent line is y minus y0 is equal to m times x minus x0. So we have a point on the graph, which was 1, 1. So y minus 1 is equal to 2 times x minus 1. Okay, do you guys see that? Yeah, they'll give you the point. You just have to put the pieces together. So they'll give you the point on the graph. So this whole formula is just slope. It's not an equation. This whole formula is just to get the slope, right? It's a rise over run formula to get a slope. And then we just put it together as a tangent line. That gives us the actual tangent line. Yeah. Yeah. Hey. Okay, any questions on this? We'll do more examples, but. Okay.
You're not given the point, you can still find out your slope, right?
Yeah, if you're not given the point, you still get the slope, but you technically do get the point anyways, because they'll give you like an x value, which is 1, and then the y value is f of 1. So you technically do get it as you're plugging things in. Yeah, so let's say they didn't tell you the point was 1, 1, they just gave you the x value, which is 1. you can plug it into the function to get,
If you're not given any point.
if you're not given any point, well, then you still need the function though. You still have the function. Like, let's say they want the slope at A, if they're not, like, they don't give you a number. They just say, find the slope at A. Then you would still use the function and plug in A. And in terms of the tangent line, the point is A comma f of A. So if you write it symbolically, it's y minus f of A, which is the y value, is equal to the slope x minus A. Okay. That's just a symbolic way of writing it. Right, but the slope of a tangent line, it comes at a point. So either we get the point because they tell us the point, or they give it to us symbolically as A comma f of A. Okay. So either way, we get a point out of it. For us to use the slope. So how about this one? So use the same function. Why don't you guys try? So try doing the same thing. Compute the slope at 2. This is A value equals 2. So try to do the same thing. Right, but pick A equals 2 and get the tangent slope at A equals 2. So it'll be very similar. So write it out. Okay. So you at least want to start there. Right? You want to have the formula, and the A value here is 2. So that's going to be your first step, and then plug everything into the function. Slowly work through this. Limit as h goes to 0. Okay, actually, this first step gives students a lot of trouble, just plugging in 2 plus h. 2 plus h quantity squared minus f of 2, right? And what's f of 2?
Squared.
Right, 2 squared, right? 2 squared. Okay, were you guys able to get that far? Yeah. What did you guys do next? Right, what do we do? Foil it out. Okay, what do we get?
H squared.
What?
Plus 4h.
4 plus
H squared.
plus h squared plus
4h.
4h minus 4 divided by h. Right, 4's cancel. We get h squared plus 4h divided by h. What do we do? Factor it. How do we factor the numerator?
H times
H times
h plus 4.
h plus 4 divided by h. And then what?
Cancel h.
When we plug in h equals 0, what do we get? 4. Guys, you guys see that? Yeah, so very similar. So it doesn't matter what A is. A could be anything and we'll still do the same algebra. And we'll get a slope. We'll get a slope. Remember, this is just slope. It's not an equation. So you have to differentiate. Is the problem asking you for slope or is it asking you for an equation? So slope is a number. So if they're asking you for slope, you're going to get a slope. If they're asking you for an equation of the tangent line, then you have to write down an equation, right? What would be the equation here? Right? How do I start? Y minus, right? What's the Y? What's the X value? Well, first of all, what's the X value? What's the point that we have? X equals 2. That's the A value. What's the Y value? 4. It's 2 squared. The function gives you the Y value. The Y minus 4. Now, the most important piece is the slope. What's the slope?
4.
4, right? That's what we calculated. Times X minus 2. So that's it. And that's giving you the tangent line. Right, so stock portfolio example, could someone tell us what this means in terms of our stock portfolio? So what does it mean? At year number 2, how fast is our portfolio rising? $4 per year, right? A slope is a slope. You could also think of as a rate. So at 2 years, $4 per year. So we're doing good, right? Because at 1 year, it was only rising $2 per year. But things got really good for us. At year 2, it was increasing much faster. It was rising at $4 per year. So that's the idea of having a slope of a curve, right? Because depending on where you are, the slope is different. So that was the big insight of, the founder of calculus, Isaac Newton, is that we could actually get a rate of change at any point of the curve. Because a line, the rate of change stays the same, but a curve, it varies. So that was the idea, is to use this slope of a secant line to get a slope of a tangent line, which gives us the rate of change at any point of the curve. Right, so that's the big insight here. Let's try another example. We'll do another one. Sample. So find equation
he's like, oh, yours is a lot.
So find equation of tangent line
Wait, hold
to hyperbola. Okay, you don't have to know what a hyperbola is. If you do, that's great, but it's just a function here. So here's our f of x at 3, 1. Okay. Right, so the first step, what we really need, step one, is we need the slope, right? The first thing that we do, get a tangent line is a slope. What's the a value? Meaning which x coordinate are they asking our slope for? Yeah, they always have to give it to us, Layla. 3. So, tangent line at 3. So the way you guys start this off is you put into the formula for rise over run. So rise f of 3 plus h minus f of 3 over h. Okay. So just so you guys see, we're always using this formula right here. All the problems. Every single problem. In this section, 2.1, 2.7, 2.8, it's all going to come down to this formula for slope. It all comes down to this. Okay. Try it on your own before I do it, right? Plug in 3 plus h, plug in 3, and see if you could do the algebra. It's a 0 over 0 limit. Okay. So you should be able to do algebra until the h in the denominator cancels. That's the idea. It's guaranteed to cancel eventually.
Criticize me, you know, people agree.
Were you guys able to get step 1?
Yeah.
Like this? Okay. Make sure you could at least get step 1. Remember, I see a lot of weird things plugging in 3 plus h. So if you wreck up plugging in 3 plus h, you get the rest of the problem wrong. Like everything you do after that becomes nonsense. So this is one of those problems where if you mess up the pre-calc or algebra, you don't know how to plug in 3 plus h. It's one quantity. Think of it as one word. It's not like 3 plus h as 3 words. It's 3 plus h. So the input is 3 plus h, right? Wherever you see an x.
I used like the wrong formula, I think I just like mixed them up, but like, why did you do it like that?
That's the formula. So here's f of x.
Yeah.
And this is the formula for slope, rise over run. So the input here is, so it's f of 3 plus h.
I see.
So the input is 3 plus h, and I substituted x equals 3 plus h for the input.
Oh, I see what you mean now.
And then
I
here it's f
figured
of
it was
3, the input is 3. I substitute x equals 3 for the input. But in terms of this formula, it's always going to be the same one. You're always going to be using this one.
Yeah, that's what I did.
Yeah, so it's always this formula for slope. The question is the pre-calc, right? Students have a lot of trouble just plugging in a plus h. They're not sure like what's going on with this a plus h business, right? But what's the business? A is a number, h is a number. When you add two numbers, you get a number. A plus h is a number. You're plugging in a plus h, the number a plus h for your input x, wherever you see an x. Okay, so this is the most important line. This is almost like half the credit if I see students do that. It's just, I have to do it because I see so many mess ups. So I might as well give half credit just for doing what you're asked to do in pre-calc. Okay, that's your input. Now this is a 0 over 0 limit that involves fractions. We had a trick to deal with that. Yeah, I get.
So what I did is multiplied both numerator and denominator by 3 plus h.
Right, 3 plus h. So you combine fractions basically. Yeah, so what Egg is saying. So 3 and 3 become, we can write it as 1. And to get a common denominator, so our trick for this was common denominators. And Egg was saying the common denominator here is 3 plus h. So he's saying, so let's just do 3 plus h numerator, 3 plus h denominator, and combine the fractions. Okay, so take a minute, try that, guys. If you didn't get that far, see if you can combine the fractions and cancel the h. Limit as h goes to 0. The numerator, remember, it's 3 minus parentheses 3 plus h. Okay, so also be careful with your algebra and parentheses. And then the denominator is 3 plus h divided by h. Okay. And now we could simplify it. Right? What's 3 minus 3 plus h?
Minus h.
It's negative h, right? Okay. That's where I see, the fatal mistake. Students forget the parentheses and the 3's don't cancel and they get really stuck. So make sure you have those parentheses. So negative h in the numerator. And the denominator, well, 3 plus h is in the denominator. H is also part of the denominator. So it's h times 3 plus h. We can combine it all in one fraction. Remember in algebra, fraction divided by a fraction could be combined as one fraction. Okay, what do we do now? Cancel the h, good. So 1 in the numerator, negative 1 numerator, h goes to 0, so what's the final answer?
Minus 1 over 3.
Negative 1/3. That's the slope, that's the m. Okay. Matthew,
You go over, when you did the 3 minus and then parentheses 3 plus H.
oh, how did I go from this line to this line? Or how do I go from this line to this line?
Yeah. How you went from that to that?
This to this?
Yeah.
I'm just using A over B divided by C over D. Is dividing by a fraction is multiplying by the reciprocal, so it's AD divided by BC. So that's what I had here. H is the same thing as H over 1. So I could always take a fraction divided by a fraction, write it as one fraction. Yeah, so here I have 1 times the numerator. The numerator is negative H. And then the denominator is 3 plus H times H, which is what I wrote here. Okay. So you'll have to use your whole algebra arsenal to simplify these until you can cancel the H. Matthew, did that answer your question?
I'm more confused about, where you got 3 plus H under the 3 minus 3 plus H. Yeah, right there.
Where did this come from?
Yeah.
Oh, well, here, so you're asking about this step to this step.
Yeah.
Yeah, so this step to this step, well, first I just had a 1 there. With the
Yeah.
combined fractions, I need a common denominator. So I took the 1 and I multiplied 3 plus H top and bottom. So now their common denominator is 3 plus H. I get a common denominator.
Oh, you're still subtracting.
But I'm still subtracting, so I get the numerator of the first fraction minus the numerator of the second fraction. So I'm just subtracting 2 fractions. Yeah. Still subtracting 2 fractions. Yeah. That answer it? They asked for the equation though. The slope is not an equation. What do I do to write an equation though? Slope is part of the equation, but what do I really need? Yeah. I want the equation of a tangent line. So they gave me the point 3 comma 1, and I have a slope. So for the equation, y minus 1 is equal to negative a third, which is a slope, x minus 3. Like that. So look carefully what the problem asks. Did they ask for slope? Or did they ask for equation? Either way, you have to get the slope. That's the most important part. But to get the answer right, you'll have to write down what they're asking you for, the slope or the equation. Okay, questions on this? Yeah, you guys see how we did it? Okay, so velocity, so it's the same idea, it's going to be the same formulas, but we're going to just interpret them as velocity. Right, so you'll see, suppose S equals f of t is position of object at time t. So we have a, let's say 0, we have a car, or we have a person, right? So we have his position, he travels here, he can go back. So we could track his position at any time t as he goes. Which is given by a function. If we try to graph it, it will be t comma f of t.
Yeah.
Can calculate always use this. Position, place, position, just position.
Okay, so this is the position of the object. Okay, what happens if we take a secant line with the position function? Right, from P and Q. Right, so if we take a secant line, if we take a secant slope of the position function, well, what would that be? That would be, again, the same formula, f of b minus f of a, right, divided by b minus a. Right, but in physics, this has a meaning, right? This is position at b minus position of a, that's the displacement. This is change in s. And the denominator, the variable is change in t.
It's average velocity.
Right? Average velocity. So the secant slope actually represent average velocity. So v average from A to B is just a secant slope. The secant slope gives you the average velocity. Okay. So if I get a slope of a tangent line for position, I get an average velocity. But what would a tangent line give me? What if I take the tangent line of the position function? Okay, so if I'm taking, remember, a tangent line takes a bunch of secant lines and brings them close together, right? So instead of an average, it's what it's called the instantaneous velocity. It's the velocity at a certain point. That's if I do a tangent line. So the definition for the instantaneous velocity. And it's a fancy name, but what's the instantaneous velocity? It's just when you look at the speedometer of your car and I tell you, what's your speed right now? And you look at the speedometer right now and I'm going 90 miles an hour. I don't care if it says 60. Your instantaneous velocity is 90. That's what it is. Okay. It's your velocity, your speed at that moment. Okay. And the way we get it, we just take a whole bunch of averages. It's a slope of a tangent line. So instantaneous velocity of object
No.
with position f of t at t equals a. So the velocity at time a, meaning tell me your speedometer right now, or the cop will with their radar gun. Okay. How is it measured? Well, it's the slope of a tangent line. Its limit as h goes to 0, f of a plus h minus f of a divided by h.
Same formula?
Exact same formula. Right. So if we take our formula for slope of a tangent line, if we translate it to physics, it's telling us velocity, right? We can measure velocity at any time. Right, so you could think of this as, right, this is change in S divided by change in T. So f of t is your position function, right? So the object has a position f of t at time t. So f is measuring the position of the object. Right? This is the physical setup. And that's what it is. It's the exact same formula. So the problem will ask you, it'll say, here's a famous position function, f of t is equal to 4.9 t squared, let's say for an example. 4.9 t squared. This is talking about a free fall object. So when you're talking about an object in free fall, you'll have a position function, just drop a ball from a building. We'll have a position function like this. It's accelerating. Okay. Find average velocity from t equals 5 to t equals 5.1. Okay. So average velocity is just a secant slope. Right. Average velocity is just a secant slope. So V average from 5 to 5.1 is going to be your 2 points here are 5, comma f of 5, and 5.1, comma f of 5.1. So it'll just be 5.1 squared times 4.9. That's f of 5.1. Minus the other y value, which is f of 5, which is 4.9, 5 squared, divided by 5.1 minus 5. So then that'll be 49.49. I think this is measured in meters. This is meters. And time here is seconds. So meters per second. That's the average velocity. So that's the slope of a secant will give you average. Okay. Between two positions. If they ask you for instantaneous velocity, if they ask you for V of 5, well, then V of 5 is going to be your tangent slope. Going to be the limit as h goes to 0. F of 5 plus h minus f of 5 divided by h. Okay. So in the interest of time, I'll do this next time. But it's going to be the exact same algebra as we did for tangent slope. Right? The whole idea is to connect the two concepts. The tangent slopes will give you the instant velocity. We'll do that next time. Pause here if you guys have any questions.
Yes. Just like.
Yes, they gave you now you need Q. Q is 8.9, right?
Yeah.
Q is 8.9. And then you have to get the Y value, you plug in 8.9.
What's the major?
4 divided by 8 minus 8.9.
Hey, est-ce que vous avez
Yeah, shut up, John. Shut up.
Ah, 4.
This guy switched already 3 times. so-
Nah, since I'm a computer science,
Tim,
electrical engineer.
You can't.
No, but he's stuck. It's 2 different stuff.
Then your slope.
Physics is mandatory for you, right? You gotta take physics.
4 over negative 0.9 minus negative 4 divided by 8.9 minus 9. So if you input this, it'll probably even mark it incorrect. It actually doesn't.
Thank you. Thank you.
It's correct, yeah.
Just finish this now.
Let's see.
But next. I
Divided by
next class.
negative
Let me just do it
0.9.
now.
Yeah.
Please just give me like 5
Well, the
minutes.
thing is, they want 6 decimal places.
They all left.
You don't want to round it. They want 6 decimal places. You'll have to write like negative 4.44444.
Okay.
And then plus 4 divided by
Not my chips.
negative.
I don't want it
If you keep the decimal, it should work out.
Okay.
I definitely.
That's
Because I might not be great, but my body definitely is.